So there we go. In this case, you will see that you do come up with a positive number. Notice it's a minus negative. So the negative 196 newtons here will turn into add 196 newtons. And then over here you have less than 80 or less than negative 80. Because oops, I didn't mean to do that one. That occurs in negative is introduced here because it's to the other side. So you have, actually it comes out to 40 newtons. So you have negative 40 newtons plus 196 newtons, and you come up with a positive number for the normal force. And now you go here and you figure out what the coefficient is. Coefficient of kinetic friction, which is negative Fk divided by the normal force. That negative still has survived from over here, just put it on the other side, and then the kinetic frictional force is negative itself, so it's a negative negative, which is a positive, divide by another positive number, comes out with a positive number. And when you look up coefficients of kinetic friction, they're always given as positive numbers. You will also notice that you come up with a number between 0 and 1 because that's what they're defined. In this problem it says the helicopter in the drawing is moving horizontally to the right at a constant velocity, so v equals constant. The weight of the helicopter is 53,800 newtons, so negative 53,800 newtons. The lift force L generated by a rotating blade makes an angle of 21.0 degrees with respect to the vertical. And I mentioned that I want to use angles from the positive horizontal. So here, so it would be of course 69.0 degrees. Theta equals 69.0 degrees, because then we associate the cosine with the horizontal and the sine with the vertical. What is the magnitude of the lift force? So L equals question mark, and determine the magnitude of the air resistance that opposes the motion. So we have a question mark here and we have a question mark there. Okay, so over here the forces that we have is, we know what the weight is, we don't know what the air resistance is, we don't know what the lift is. Do we know what the mass is? Yes, actually we do, because it's right here. Mass equals, so divide this one here by a negative 9.8, and we come up with 5,490 kilograms. So we know what the mass is. Do we know what the acceleration is? Yes, we do, because constant velocity means that the acceleration is 0. Okay, so I'm going to write it down. Sum of the forces equals mass times acceleration. So we have air resistance plus lift plus weight equals 0. Again, I write everything as a sum using pluses in between. Okay, we don't know the lift, we don't know the air resistance, so we have one equation with two unknowns, so we have to come up with two equations, and that's simply done by writing them in components, x direction and y direction. So in the x direction we have air resistance, which we don't know. This one here eventually has to come out to negative because it points to the left. The lift is going to be the lift, which we don't know either, times the cosine of 69.0 degrees. because cosine of 69 is positive, that one here has to come out to a positive number. Makes sense because the lift is pointing to the right. Plus 0 because the weight, there is no weight in the horizontal, and that equals 0 because the acceleration is 0. So remember that this one eventually will come out to a negative. This one here has to come out to a positive. Okay, in the y direction we have no air resistance, so that's a 0, plus L times sine of the angle theta. Sine of 69 degrees is positive, so overall this one comes out to positive. Plus the weight, so that's negative, and that equals 0. So here we have a positive and a negative, and that comes out to 0. Okay, in the second one, because we only have one unknown here, the L, we can calculate that right away. So lift comes out to minus weight, because we get this to the other side, so it's negative weight divided by sine of the angle. Okay, here we have negative of a negative, so it comes out to a positive, divided by a positive sine theta, so that's a positive number. And then we go over here, r equals negative L cosine theta. And now from what we figured out down here, for the lift, we're going to figure out what the air resistance is by plugging in the numbers, and we also come up with that because we have moved this stuff here to the right hand side that introduced a negative, so the air resistance is going to be negative, and that makes sense when you look at the drawing because the air resistance points to the left. Okay, this one I'm going to check, even though I don't have any numbers here, I'm going to check with the vector addition applet that I found online. So I'm going to use the numbers that are given so far, which is for the vector, the weight, let's see, that was 53,800, and I believe I'm just going to use 538, and that one is down, so that's going to be negative, I tried negative 90 degrees, okay, that didn't work, so I'm going to try 270 degrees. There we go, down, and then it's a little bit long. Yeah, let's see, might have to, there we go, it might work just a little bit better. There we go. Okay, and now it turns out that I actually don't know the other two, so at this point I actually will give away the answers, and that is for the air resistance. I've come up with 20,700 newtons, which I write as 207, and it's pointing to the left, so that's 180 degrees. There it is. And then I add a vector to this one, which is the lift. And a lift, again, I will give it away, 57,600 newtons, so 576, because, you know, I have to write them a little bit different in this applet here, and that is at an angle of 69 degrees. And there it is, and when you look at the diagram, you add the three vectors tip to tail, you come up with virtually a 0 here. In fact, we can check. It says show the resultant, and the resultant comes out to 0.63, which is 63 newtons. I had to change the scale here, and 63 newtons is so small compared to these tens of thousands of force that we consider that really 0. And now I insert it here and turn it so that it would fit on here, and you can see that, well, tilt your head sideways and you can see the lift force and the weight pointing down and the air resistance pointing to the left.